Sensor, transducer, transmitter. Walk any plant, and you will hear those three words used as if they all mean the same thing. They do not. One of them is buried inside the next, and only one of them ever lands on your PLC. So which is which? In this video, I will pull the three apart from the bottom up. First, the sensing element, the part that actually feels the pressure. Then the transducer, which turns that into an electrical signal. Then the transmitter, which makes that signal survive a long, noisy cable run. Get the chain straight, and every pressure device on the floor stops being a mystery. Let us start at the bottom. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC analog scaling and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the sensing element. Start at the very bottom of the stack. The sensor. This is the element that physically responds to pressure. There are a few common types. A strain gauge bends, and its resistance changes. A capacitive cell moves a diaphragm, and the capacitance changes. A piezoelectric crystal gets squeezed, and it produces a tiny charge. Whatever the type, the job is the same. Turn mechanical pressure into some raw physical change. But here's the catch. On its own, that raw element gives you a tiny, fragile, non-standard output. Nothing on the floor can read it directly. So the sensor is real, and it is essential, but it is only step one. Now add the next layer. A transducer. A pressure transducer is the sensing element, plus the electronics that convert its raw response into a usable electrical signal. Usually that is a small voltage, a few millivolts, sometimes a 0 to 5 volt or 0 to 10 volt output. So every transducer contains a sensor, but it adds the conversion step. That is the whole idea. Sensor plus a low-level electrical output equals transducer. And for a lot of bench and short-range uses, that is enough. The problem shows up over distance. A few millivolts will not survive a long cable run through a plant full of motors and drives. The noise eats it, which is exactly why the third device exists. Here is the top of the stack. A transmitter. A pressure transmitter is a transducer plus signal conditioning. It amplifies the signal, it linearizes it, and it converts it to a standard, transmittable output that travels over distance without falling apart. In industry, that output is almost always 4 to 20 milliamps, often with HART riding on top of it. Why current and not voltage? Because a current loop does not drop off over a long wire the way a voltage does. So the transmitter is a transducer packaged to send a robust, standardized signal straight into a PLC analog input. That is the difference between a transducer and a transmitter, the conditioning and the standard output. I cover scaling that 4 to 20 milliamp signal into real engineering units in the linked analog input videos. HART gets the linked HART explainer. Two more things you will run into. First, the reference. Pressure is always measured against something. Gauge pressure is measured against the local atmosphere. 0 means atmospheric. Absolute pressure is measured against a vacuum. 0 means a true vacuum. And differential pressure is the difference between two ports, which is how you measure flow and level. Same device family, 3 different reference points, 3 different meanings for the number. Second, switch versus transmitter. A pressure switch is discrete. It trips one contact at a set point, on or off 1 bit. A transmitter is continuous. It streams the whole measured value all the time. I dig into the switch side in the linked pressure switch video. The point here is simple. A transmitter gives you the full reading, not just above or below a line. So here is the chain to walk away with. A sensor is the element that feels the pressure. A transducer is that sensor plus an electrical signal. And a transmitter is that transducer plus signal conditioning, sending 4 to 20 milliamps to your PLC. Each one wraps the one below it. And the transmitter is the one you actually wire up. Get that? And the words stop tripping you up? Now go make it concrete. If you want to practice scaling a 4 to 20 milliamp pressure signal hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, New video every Tuesday. See you in the next one.